Hello and welcome to this video on limits. As promised, we are going to go through how to evaluate limits in this video. But first of all, a disclaimer, this is not in the syllabus of AMATS 4049. So if you want to skip this video, please go ahead. But if you are someone who is genuinely curious about how the world works, you have an insatiable hunger for knowledge, then this video is for you. And besides, if you're taking A Math, I would dare say that you will most likely be doing H2 mathematics in junior college, or you'll be taking the tougher math modules in Polytechnic. Then you're going to learn this anyway, so might as well read about it now, right? Then you get to have a bit of insight into the things you're going to learn next time. Okay, without further ado, let's look at the questions in this worksheet. So if you look at the first page, we have 4 questions. And in some of these questions, you look at the expression, you look at the limit and you're like, wait, do I even need to take limits for these expressions? Okay, so just a quick review from the last video, we talked about how using limits is like a tool that allows us to look at places we can't get to. Yes, like Google Street View, remember? Yeah. So in these cases, if you look at say 1a, right, what happens to x when x approaches 1? You're thinking to yourself, wait, I can get to 1 itself. There's nothing wrong with that. And you're right. We can solve this question by just using substitution. We don't actually have to use limits. So what happens is that there's nothing wrong with x equals to 1 for this expression. So I'm just going to do a simple substitution. And the answer is 1. Very simple. Yeah. If you look at b, right? B is looking at the expression x over 6. Well, x over 6 is just a simple linear graph that passes through the origin. What happens when x approaches 12? Well, I can even tell you what happens at x equals to 12. You don't have to approach it. So we can actually just substitute x equals to 12. 12 divided by 6 is 2. And that is the answer, right? That is 2. Okay. Part C. Well, we are looking at the limits of 9 over x as x approaches 3. Well, for 9 over x, I know how to sketch the graph. It kind of looks like this. Yeah, one side is like that, the other side is like this. Okay, I want to know what happens when x approaches 3. So maybe 1, 2, 3. What happens when x gets nearer and nearer to 3? Well, actually, I can tell you what happens at 3. There's nothing wrong with that. So we can just substitute x equals to 3. And that'll be 9 over 3, and we get 3. This value here is going to be 3. Yeah, so nothing wrong with that. Okay, we can do the first 3 questions just by simple substitution. Now let's look at D. Right, let's look at D. 1 over x is also quite similar to this graph that I sketched. And then you say that, hey, why don't I substitute x equals to infinity? Well, here's the problem, right? Infinity is not a number. Infinity is sort of like a concept of a number that's really, really, really big. Okay, so I've been saying it many, many times, but maybe today I'll finally explain a bit more by what I mean. Infinity is not a number as a concept. So what I've drawn here is like your house, your home. Okay, and sometimes you are perfectly fine to go to the food court or the supermarket in just slippers, shorts, and an old t-shirt, right? You're comfortable going around the neighborhood, right? Maybe this is the radius of your neighborhood, right? You're totally okay doing that. But say if your friends ask you to go to MBS, Marina Bay Sands, and you will be like, no, I'm not going to wear slippers, shorts, and no t-shirt. I'm going to dress up and wear something nice before I go out, right? So this radius over here in dotted line is what I would describe as the radius of like what you'll be comfortable wearing slippers and shorts. Anything out of that, you will not consider. You will not entertain the possibility of going that far wearing, say, informal clothes. Yeah. So anywhere outside of this circle, you just would not be comfortable going around in slippers and shorts. Okay. And this area outside of the circle is very similar to infinity, right? Infinity are numbers that are very big, that we are not ready to deal with just what we know right now. Yes, so most of the time, infinity is not a number, but it is just an area that we are just not interested in, not so interested in. Huh? Okay, So that is why you cannot substitute infinity inside here, because it is simply not a number. So what we can do is actually we can look at a table of values. Yes. Let's see what happens when I change values of x. How does 1 over x change? Okay. So let's start off with a simple value. What happens when x equals to 1? Well, then 1 over x becomes 1 over 1. That is 1. What happens when x equals to 2? Then you have 1 over 2, which is half, 0.5. What happens when x equals to 10? Then 1 over x is 0.1. What happens when x equals to 100? 1 over x becomes 0.01. And when you have 1000, it becomes 0.001. And as you can see, as the numbers gets larger and larger, the number of zeros after decimal place increases. It becomes 0.00000001. And because of that fact, we can say that, hey, the limit of 1 over x as x approaches infinity is just going to be a big fat 0. Yeah, it's just going towards that number. Okay. In fact, this is quite an important result that we will be using quite a bit over and over again. Yeah, so you need to remember that. Okay, another way that we can remember this is to look at a graph. Okay, or we can think of this table as, hey, here is the input and here is the output, and usually we represent the output with y. So if I had to sketch the graph of this, right, we can get a good idea what's going on. And over here we have decimals. I plotted the graph y equals to 1 over x, and you can see what happens, right? When x equals to 1, remember just now we were over here. When x equals to 1, y equals to 1, or 1 over x is equals to 1. When x equals to 2, right, 1 over x is 0.5. Sorry about that. Huh? And when x equals to 10, you can see 1 over x is going to be 0.1. Okay, and as we move on and on, right, as we zoom out and we go really, really far away, you know, like 12,000, you can see, right? The number is so small, decimals has already think that it's 0. Can you see? Yeah, somewhere around here it already says that, hey, you know what, this is as good as 0, because it's just getting too small for us to deal with. Yeah, so that is why we say, hey, as we go towards this direction of positive infinity, well, this thing is just going to be 0. Okay, yeah, okay, let's look at the next page, where we have slightly more difficult questions, but not that difficult actually. Let's look at question 2a. Now, if you look at question 2a, we want to find the limit of this expression, x over x, as x approaches 1. And you'll be thinking, what? This is so silly, we can simplify the fraction, right? So I have my reasons for doing this, because I just want to explain something, yeah? But let's just play along and say, if we don't simplify the fraction, what can we do? And then you can look at this and say like, hey, can I do a substitution? Can I substitute x equals to 1? And yes, you can do so, right? This is actually just the limits as x. No, when I substitute, I already taken limits here. So this is just going to be 1 over 1. Okay, and this is just 1. Yeah. So the limit of this expression as x approaches 1 is just going to be 1. Yeah. Okay. But if you look at 2b, we have the same expression, but now x approaches infinity. Now you can't just go about substituting infinity into the numerator and denominator, because infinity is not a number. What can we do? And here is where you have to simplify your fraction. So if we simplify our fraction, we're going to get x divided by x. That's going to be 1 over 1, which is going to be this. Okay, then we ask ourselves, what is the limit of the expression 1 as x approaches infinity? Again, I can plot a graph for this expression. First, I let y equals to the expression itself, which is y equals to 1. I think we know how to sketch this. Y equals to 1. It looks like this. Y equals to 1, yes? This is y equals to 1. And now the question is, as x increases towards infinity, what is going to be the value of y? Remember we did y, x equals to 1, x equals to 2, x equals to 10, so on and so forth. What happens when we say approach infinity? Yeah. What is going to be the y value? And you can be sure about it. It's going to be 1. Because y equals to 1 is a constant. The value doesn't change. That's why we call it a constant. Yeah. It's going to be 1 forever and ever. So this is also an important result. It tells us that the limit of a constant as x approaches any number, actually, not just infinity. It can also actually approach negative infinity if you want. Yeah, negative infinity will be on this side. Say if I extend this black line, dot, 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 and then you have a negative infinity here. Well, I can tell you that y is going to be 1. Yeah, so I can say that, hey, the answer is just 1. And this is an important result. Yeah, the limit, let me write this somewhere else and maybe in a different color, purple. The limit as x approaches infinity or negative infinity of a certain constant a is just going to be the constant itself. Yeah, this is also something that we keep using again and again. All right, good. Now let's look at 2c. 2c is finally something that we might see in our question papers in our practice. Yeah, so how do we do this? Okay, the first question you should be asking yourself is, can I do a simple substitution? Let's check. So if I try to substitute x equals to 2 to the numerator, this is going to be 4. 4 minus 4 is 0. 0 in the numerator is totally okay. Let's look at the denominator. In the denominator, if I let x equals to 2, 2 minus 2 is 0, and that is not okay. Because we cannot divide by 0. Dividing by 0 is not allowed in mathematics. When you divide by 0 in mathematics, you get a non-answer, which is undefined. Yes? So when x equals to 2, this expression does not return any results at all. Right? It does not return any results at all. Okay? And that is why we have to use limits to find out what happens. Yeah? What happens? Okay? When we substitute x equals to 2, we have no idea what's going on. Just a blank picture in our head, right? So we use Google Street View to take a look at what is going on near 2. Then we'll have an idea what's going on. Huh? So let's take limits. When we take limits, and you can see that level 2, the questions on page 2, is about factorization. What do you think we can factorize? Okay, and you can see the numerator is a difference of 2 squares, isn't it? And to factorize difference of 2 squares, a squared minus b squared is going to be a plus b into a minus b. Okay, and then this is the denominator. How convenient, right? We can cancel this off. Okay, but we are canceling these two linear expressions in the numerator and denominator on the premise that x is not equals to 2. Because when x is equals to 2, what happens? This is going to be 0, this is going to be 0. You cannot divide anything by 0. Again, you cannot divide anything by 0. It's going to give you a non-answer. Yeah? So, because the question says, hey, we are just approaching 2. We are not at 2. So that is perfectly fine. Right? We know that x is not equals to 2. We can cancel those off. And then this becomes the limit as x approaches 2 of this expression now. And you look at yourself and like, hey, wait, that looks rather simple. Maybe now I can do the simple substitution. And you should, right? If you do the simple substitution, you're going to get this. And that tells us that, hey, you know what? The limit of this expression, had I just done a simple substitution, is utter rubbish, total nonsense. But if I use Google Street View, I can see actually it is going towards 4. Yeah, it is going towards 4. Right? That is quite very interesting. In fact, maybe I'll just take some time to go on decimals and plot this out. Yeah, x squared minus 4. Let's do this. X squared minus 4. All of this, oops, is divided by, I don't want that, x minus 2. Oops. And I seem to zoom in too much just now, so I just want to go back to here. And you can see that when x is equals to 2, x equals to 2, can you see at x equals to 2, there's actually no answer to this, it's undefined. But you can see that, hey, it's really, really close to 4. When it's 1.99999, it's about 3.99. When it's 2.01, or rather somewhere near 2, yeah, it's around 4-ish, 4. So we can say that, hey, this thing is going to approach 4. Yeah, Okay, but at x equals 2 is undefined. But yeah, with Google Street View, we know that is around 4. Okay, and finally, let's look at 2D. Okay, for 2D, you may pause the video and try it yourself. It's something similar to question C. All right, before I review the answer. And here we go. I'm going to do the answer right now. Okay, so to look at this, and we want to factorize this. Oops, let me just give myself some space here. We need to factorize the numerator, and you should learn this before, right? How do we factorize this? Well, this is a difference of cubes or a sum of cubes, and we know it can be factorized into a linear expression followed by a quadratic expression following the SOAP rule, right? SOAP tells me that the sign will be the same as the negative sign here, same. Then it'll be opposite over here, and then it'll be always positive. Same, opposite, always positive. Okay? So what that means is that this is going to be x minus 1, and this will be x squared, x 1. All right? So that tells me that I can re-express this as x minus 1, x squared plus x plus 1 divided by x minus 1. And how convenient, again, we can cancel these out on the premise that x is not equals to 1. Yeah? So sometimes we write this at the side saying that, hey, this is allowed because x is not equals to 1. We are approaching 1, we are not at 1. Okay? So the limit as x approaches 1 becomes this expression. And then you ask yourself, wait, this looks surprisingly simple. And then maybe I can do a simple substitution. You're right, let's do a simple substitution. This becomes 1 squared plus 1 plus 1, and that becomes 3. And that is the limit of this expression over here. Okay, had you just done a simple substitution, you would have gotten an undefined answer. Yes, but using limits, using Google Street View, we go around the area, be like, oh yeah, seems to be going around 3. That's what it seems to be. Okay, so I come to the end of the video, but you realize that I have a few more questions to go, and those are the more advanced questions. Again, not in your syllabus, but good to know, but I'll just make a separate video. Okay, if you're interested, you can check it out. If not, you can skip ahead to the next video where we talk about differentiation. Until then, thank you for watching, and I hope to see you in the next video and catch you on the flip-flop.